Hey guys, welcome to this third tutorial on processing in the season 2. And this tutorial, as you've seen already, we will be doing it in Eclipse. We showed in tutorial number 24 how to install Eclipse and how to start using it, but it would be really useful to start doing some examples on it so people that have doubts can actually start jumping in and using this much more powerful platform to develop processing code and Java code in general. So notice that I have installed the Proclipsing plugin for Eclipse, as I've shown in video 24. So that would be the starting point. If you don't know anything about Eclipse, go to tutorial number 24 and then you'll find all the information and the documentation to follow along. So let's go ahead and just create a new project. And you see here that I pick Proclipsing project, say next. So here what I'll do is just maybe pick some of the libraries I'll work with, like OpenGL, and definitely like Control P5 perhaps, and TOXIMESH and PCCam. So PCCam is here and TOXIMESH is here, and you can see that we need to give a name to this. We're gonna say TOXIMESH, right? Because we're gonna be dealing with a mesh today. Right, so we'll see that, and let's say finish. And basically the plugin, the wizard, actually created a project for us, and it should be, we open here the source folder, the package TOXIMESH, and we have our Java file, and this is what we get, right? An extension. Now that we have covered inheritance, we know that what that means. So our class TOXIMESH extends papplet, that is a processing class, and then we have the void setup and void draw, and we have a little icon already saying that there's something kind of wrong here. So we're gonna leave that as it is right now, and let's start working as we usually do in processing, right? So we're gonna say size 600,600, and you see that the code it has some auto completion features. Let's also put something like background 0. So we could check if this runs, and this will automatically save our code for us every time we run it. So that's kind of good. And we're waiting for this to come out, and there we go. So you see that we have a processing window as we usually do, right? So I'm going to show the power of Eclipse through making a nested structure. So I'm going to do two classes today. One is going to be a point class, as we usually do, but then I'm going to just make a grid class and call that point class inside that one. So we can start seeing what are the features of Eclipse and why it's so useful. So let's start by importing some libraries. You see that we can import here, import PC also import toxi.geom, and you see that it's actually showing us what we could do already. Also import toxi.mesh and import control P5. So these are some of the libraries we're going to be working with. And you see that we have also all sorts of icons here saying this has never been used, like, so we could actually delete this and the code would be optimized. But right now we just want to maintain that there because we will definitely use it. So let's make an instance. Let's start working in 3D already. PCCam, cam, so cam is a new PCCam. This, 100. So this is the normal way in which we do a 3D environment, right? We can actually get rid of this bit here, so we have a little bit more space. And you can see already here in the outline that we're starting to get all the import declarations, our functions are here, and it will start getting some global variables like PCCam. It's showing us an outline of all our information, so it's very neat to actually develop code. So we're gonna do a box, and notice that I don't really need right now. Actually, we're gonna do a rectangle, right? I'm gonna say from 0 to 300. We don't really need to specify anything to work with some of the values of processing, some of the functions of processing. We don't need to just call them by saying anything. We will have to do that maybe later when we start going inside our other classes, right? So let's make stroke 2 by 5 and stroke weight 1, right? So we're very simple. Again, we could say always save the resources so we don't get that annoying message every time. And we're supposed to have, right, we forgot to just specify that we're working in 3D. So we're going to say P3D. And we're going to say no field here. Right, so that's it. Again. So we do have, as usual, our library being called and working perfectly, right? So that's very good. We can see the console as well. Let's minimize this so we actually get a little bit more space as well. So how do we create a new class? We are going to create a new class saying the name of the class will be PT, like a point, right? And everything else is going to stay the same, right? When we do this class, if we want to be able to access some of the functionality and maybe read some of the information of our main class, we're going to say extends, or sorry, we need to cast our main class into this class, right? So we're going to say PT, and it requires the first argument will be a TOXIMESH class called _P5, and this will be a global variable called P5. So this is, in this way, we're actually having a version of the main tab of the main class inside each one of our classes. So every global variable is visible from inside this class, and we make this class to become the parent of everything, right? So that would be the main one, and we're going to say vector3d underscore location, and location equals underscore location. We need to create that global variable as well. So vec3d location, and you can see that we haven't, there's an error here, right? Several actually. It says 3D vector cannot be resolved. So let's see what are the options available to solve this. It would say import vector 3D. That's what we want, right? So we're going to click that, and you see that it's importing exactly the class that we need here. So that's pretty neat. It's helping us to complete the code and solve if there's any issues. So what we're going to do here is say void run as usual, and our function display. Let's make that function would be a point. So how do we access the functionality of a point, right? We need to say P5, that is the class that is extended of processing. So all the functionality of processing, now it's inside the P5. And when we say dot, we have all the possible functions that processing has. And the auto-completion is actually showing us all this stuff here. And it's actually giving us the arguments required for something like that. So we're going to say control P5, dot point, right? And we're going to say x, y, and z. We're going to say log.x, log.y, and here log.z. And we're going to do these points. Also, we need to say stroke 255,0,0, right? Or if we want them green, just do them green, right? And these points will have a stroke weight of 1, or basically 2 in this point because we want to just make them slightly bigger. So this is a very simple class, and we have created it using Eclipse. We need to call it into the canvas now. And notice that all the kind of functionality of processing now goes through this P5 instance, right? So we need to, like when we're inside this class, that it's not extended. It's not extended to PApplet class. We need to just cast the processing class, the PApplet class, into each one of our classes, right? So this is the way we're doing that. And we have all the functionality of processing through this P5 prefix, right? So let's go ahead and create another class, because what I want to do is just not call in here our points or an array of points or a double two-dimensional array, but I want to just create a class that would be a grid, right? So I'm going to click here on class again, and I'm going to say that this class is going to be called grid, right? So you see that we created a class called grid, and let's make this grid. Basically, we'll have the same situation that our point. It will use an instance of TOXIMESH as to be able to use all the functionality of processing, right? So we're gonna say here P5 equals underscore P5. Very similar thing, but in this case, the global variables that we do want to deal with, it's integer calls, comma integer rows. So the number of columns and number of rows for this grid, right? So we're going to say integer calls, integer rows, and I think these ones we should put them, if we follow our own method of structuring things, we have to put them with underscore. And columns equals underscore columns, rows equals underscore rows. So that's pretty simple. Let's put some comments here. We need to do a two-dimensional array of points inside this class. So we could already do that by saying pt array grid. How do we call this? All points, right? And all points, it's a new pt array of columns and rows, right? So we're initializing now the two-dimensional array with the number of columns and rows here. Next to that, we need to initialize each one of those points, right? So we need a two-dimensional for loop. 0 I smaller than columns I plus plus, and you see that the parentheses, each time that we open one, it's going to tell us that we have to close it, and it will close it automatically for us. We can copy the structure like this, and here we need to change for j, right? And basically what we want to do here is that all points I j plus new pt, and we need to provide some information here, right? So first is what is the instance of the TOXIMESH class, right? So we need to, the point is requiring to pass an instance of TOXIMESH, right? So we're going to just put P5 here, right? So that's the instance of the, and then it's asking us for a vector. So we need to create that vector, right? Because we want this to be organized in a grid fashion, we're going to say a vector that is I, comma j, comma 0. Again, same comment, you need to import TOXIGeometry, and you see that now this is where we're closing the constructor, and we have a very clean code that is being supported, and the IDE here it's helping us to write it properly. Right, let's check. I mean, it's already telling us that there's no problem, right? So we can be secure that we are not running into syntax mistakes. So we are initializing the points. That's good. We need now to, what could be useful here is if we use I times scale x, so basically give a scale value and j times scale y. So we can actually do something like float. We could do a float scale x and float scale y. And this could be part also of the constructor. So when we create the class, we could say the size of the grid, right? Right, so very good. We can actually create an instance of that class. Let's see what else we need. We need to be able to call some functions here. So let's say void run. So run points, we could say. So we're creating some functions, like the function run points that doesn't exist yet. So we're going to create that void run points. And basically we need to use the same for loop here. Oh, there was a mistake here. We should have said rows. That's better. Right. And we want to say all points dot run. Right. So we're going through each one of the points, and we are calling the function run in each one of them. So one thing that you could do in Eclipse is just press Command A in Mac or Control A in PC, and then press Command I or Control I to just clean the indentation in case there's something kind of strange. So at this point we should have a functional grid, and you see that our points are being part of the grid, and the grid is the one that we're going to call into the main tab, right? So let's do an instance of such grid. We're going to say grid my grid, right? And my grid equals a new grid. And here we need to also give an instance of the TOXIMESH. So this is when we use the keyword this, because we are inside TOXIMESH, and the only TOXIMESH instance that we have is this, right? So we're passing an instance of the class we are in to the subclass grid, right? So this is a good example of how you're kind of passing the information between classes, and how these classes are communicating and getting access to more of the information inside the other one. So here we say columns. We will say something like maybe 100 columns times 30 rows, and they will have a distance of 10 and 10, like the spacing between points, right? And now we can say my grid dot run. Let's see if this is running. And it seems it is, right? So we have the grid here, two-dimensional array, and the classes are nested. You have the point class inside the grid class, that is kind of the one that is controlling how many points we have. So very simple class that is allowing us to just say, well, maybe we want 131 in order to cover this whole rectangle, and maybe we want 200 points, and maybe 60, and they will be separated by 5 units. So you can see that we have a really good control over the number of points. Let's make these points slightly thinner, like more detail, to just make it look a little bit nicer, right? So now we can actually work with the points, right? What I want to do is basically consider that each point has certain neighbors around it, like a CA, and basically start building a mesh out of these points. And then we're going to provide some information for those points in terms of the height that they have. Let's say we could randomize it, or we could use some wave functions to actually get some control of that, and we could create some nice patterns with that. So let's go to the point. And the point would be interesting to know in which position in the grid it is, like some index. Because a point is part of a two-dimensional array, I'm going to just make two indices saying integer idx. So the index in x and integer underscore id y, integer idx, integer id y. Right? I just want to make sure that this point actually does know where it's located in the grid, right? And also I'm going to say idx here equals underscore idx, and idy equals underscore idy. The other thing that would be useful for us, well, right now we would have an error if we go especially in this class, because it will tell us right away, right? Like pt, let's see what the error is. It's saying the constructor that contains these two arguments is undefined. The constructor is basically asking for a bit more information. In this case, we need to provide the indexing x, that is I, and the indexing y, that is j, right? But I also want to pass an instance of this class, the class grid, into the point, because the point needs to know that its index relates to the specific class grid, right? So how do we do that? We could say maybe the second argument, just to leave our classes first and then our arguments of variables. We're going to say maybe we also need to provide a grid class called underscore parent, right? So this will be my parent, and I'm going to say grid parent equals underscore parent. So now we're requiring, give me an instance of the TOXIMESH, that is the master class that represents the processing, and give me an instance also of the grid class that it's actually controlling me as a point, right? So if we go again to the grid class, we'll see that again we get that error, and we need to give an instance here of our grid class. And here we put this, because this we are inside the grid class, right? So hopefully this will clarify why we use this and where we use it, just to basically pass the information of this class inside our point. So at this point we shouldn't have any errors. So let's make a function called draw connections, right? And draw connections doesn't exist. Let's build it. That's good. So basically, let's understand where is the point located in the grid. The point is located in somewhere in parent, right? That is the grid. So parent dot what? All points. Yeah, it's giving us here a list of all the functions and variables that my parent class has. And so parent dot all points. First square bracket defining the first dimension of the array, id x, and the second one is id y. So as a point, this is us, right? This is the point itself in which we are located. And the point also has some neighbors, right? So we could say idx plus 1, idy plus 1, and we will have some neighbors around us. So we could, let's make a few vectors out of this, right? So I'm going to say vec3d v1 equals idx, or we could call this vector me, and we will say dot and we see that we have access to the information of the points, and in this case lock. This is a little bit ridiculous really, because we do have the location directly. We don't need to access, but this is just as an example, right? We know that this is the point in which we are located. So that's a little comment. That would be me as a point. Let's do the vector, my neighbors, right? So I'm going to copy this line, and I'm going to say neighbor 01, or neighbor to the right. And we're going to say to the right is idx plus 1, right? And basically we need a few more, neighbor down diagonally, right? So this one will be the plus 1 here, and the diagonal one would be plus 1 here, right? So these are 3, and this is a comment which one would be me as a point, right? So now we have 4, the location, which I would say here equals lock, right? And let's try to make a mesh by saying begin shape, because we need to use, this is not recognized as a processing function. We will say p5 dot begin shape, p5 dot end shape, and here we could say p5 dot vertex, we would need to produce x, y, and z of basically lock.x, comma lock.y, comma lock.z. And we could just give all the vertices, and eventually we will produce a mesh, right? But this is kind of the manual way in which you would actually do a mesh with processing. Just you would give all the vertices, but I'm going to show you a nicer version of how to deal with Toxi to actually create a mesh, right? So let's get rid of this stuff, and this kind of a little example, and you would follow, maybe you would put the vertex 2 would be the right one, then the diagonal one, then the down one, but let's make a different thing here, right? So let's get rid of that. I'm going to save now. It seems that we're running into an error here. Let's see. The constructor, no, we save and it's fine, right? So what we're gonna do here is just make a triangle mesh. And I'm gonna call that mesh. This is a class from the TOXIMESH geometry mesh library, right? So mesh has a lot of functionalities and it's really good. So let's initialize that by saying mesh dot equals new triangle mesh, and we need to give it a name. We could give it a name called meshy, for instance, anything. So we have initialized a mesh, but it's an empty mesh right now. It doesn't have anything inside. What we're going to do now is, just because we have created this mesh, we can actually make our points add faces to that mesh, right? So we're going to say p5 dot mesh. We can see that it's showing us which are the variables from the main class mesh dot, and it's going to show me what are the methods inside this class. So you can see here the power of processing, of Eclipse, right? Like all this stuff, you would be having to check the documentation of the mesh class to actually decide what to put here. And then we're going to say 3 vectors, right? Add face, and we're going to say knee right is the first vector. The second one is going to be neighbor down, and the third one is going to be knee. Let's change that. Let's make the first one lock, the second one knee right, and the third one knee diagonal, right? But because it's a triangle mesh, did I spell it wrong? Apparently so, right? Because it's a triangle mesh, we can only provide 3 vectors, so we need to do this line twice for the other 3. So we're gonna say maybe knee diagonal, knee down, and lock. Right. So we're creating 2 triangles with the neighbors around me, and that would produce a quad mesh. Let's see what is the error right now. We just need to save this before. So when we save, everything seems fine. You know, like the files check each other, and it seems that everything is working correctly. So if we try to run this, we'll see that we are running in, and basically the problem here is that we are creating loads of faces. Every frame we are creating faces, right? So we need to just be able to first of all say, every frame we're gonna say mesh.clear, right? But even so, at this point the mesh won't be displayed in the canvas, because basically we're not telling the mesh to be drawn, we're just creating the mesh. And we could even export it as an STL or OBJ right now, but it wouldn't appear in the canvas. So for that we're going to use another TOXICLIPS class called TOXICLIPS support, I think, GFX. And I think, let's see, maybe this should be with that. Need to check what is the name of this class. I'm pretty sure it's this one actually. Let's see if we need to import something to actually access this class. So how do we do that? We can just go here to our folder and all the way down to the bottom. I'm just going to move this a little bit because you probably cannot see. There should be a tab that it's called Proclipsing Project Preferences, the last one, right? Probably you couldn't see it, so we're going to check here that we need this class here that is TOXICLIPS P5. We're going to say OK. So let's try now. Right, so here's a good recommendation. Change it to TOXICLIPS support from toxi.processing. Yes, so quite helpful here. Eclipse is telling us this is the name of the class that you're looking for, and you would have to import this piece of the library to actually access it. So really helpful. It did take us so long to really figure that out, and now we can initialize that GFX class. What is the GFX, you might wonder? And this time I'm just going to copy it, not to get it wrong, right? Right, so here we need to add an argument that is this, basically the processing class that we need. GFX is a support class that will actually allow us to draw very easily the mesh or other sorts of entities from TOXICLIPS, right? So we could say GFX dot, and we'll see that we can actually draw stuff like ellipses, like all the stuff that processing already has, but also meshes here. So this is the one that we're going to points, etc. So we're going to say we want to draw a mesh. And the mesh we're going to draw, it's called mesh, right? but we need to put this after our grid.run, because grid is calling at points and the points are the ones that are creating the mesh, right? So we need to just say this slightly before, just after the creation of the grid. And we could also use a different stroke to specify. Maybe we could say no stroke, and a fill that is white, right? So you can see, let's try now. At this point we should start getting something. Seems that we're getting some sort of error. Let's try again. It's trying to find the problem, okay? So we are clearing the mesh here. We are creating the faces between the points. Let's try it without the draw connections. Right, so basically without the draw connections this is working fine. It seems that we are having a problem here with the draw connections somehow. We could say .copy maybe to each one of the vectors, so we are kind of making sure that we're not so I'm making a copy of the vector as opposed to just be using the vectors themselves. And we are getting an error. We're not seeing the error because we need to yes, that was obvious, right? It's saying I forgot to just put the if statement. We need to, so if you expand this you will see where the error is, right? Like similar in processing. And I forgot completely about making an exception for the end row, right? So we need to say if idx is smaller than parent.columns, right? And idy smaller than parent.rows. Basically do all this stuff. So we're giving an exception here. Again, we're having an error. Let's see what is this time. And we're still running into that exception. Oh, I forgot that it has to be columns -1 and rows -1. Excellent. So you can see here that we have created a mesh. You cannot really see it too much. Let's make the wireframe visible and maybe use less points, right? So let's do 101 and 31, 10, 10, and we're gonna say instead of no stroke, stroke 255, or sorry, 0,90, and we're gonna comment out. Let's just use something like 100, like a gray, not to be so radical in the color. Yeah. So you can see that we're creating this mesh, right? So at this point we could actually put some height to this point, right? Let's make to see a little bit more of that mesh quality. I'm also going to turn on lights by typing lights here. And I'm going to go into the point and say a function like set height. or basically here, just in the constructor, we could say that log.set equals random 200. You see that the function random doesn't exist here. We need to call p5.random, and then we have. So let's see what kind of jagged terrain we get out of this. So you can see that the points have been moved up and down with a random value. We could be less radical about that and say maybe 50. And you see that we have the height of the points and the mesh. It's actually working quite well. At this point, a TOXIMESH has functionality to be exported into other software packages, right? I think that this tutorial is already kind of long, so I'm going to leave some of the functionality of the waves and the functions that I wanted to work on in the heights for the next one. But I'm going to show you how to just export this mesh, right? So let's make a function like let's make some space here so we can just look at it better and say void key press. And we already have an error, and we need to add public somehow. Wasn't sure for that, but anyway, Eclipse is helping us here to complete. So we're gonna say also if k is e for export, we can say mesh dot save as obj or save as STL, and basically we need to specify here the stream, or basically what is the output. So we're gonna put something like sketch path. I never remember this, so I'm just gonna go and check it on somewhere else. Right, so I got a little bit of a. So this is what we have to put here: sketch path mesh.name plus obj. And in this case, if we press E, we will be exporting the mesh, right? So let's try it. Right? Oh, sorry, one mistake here. It should say STL, right? There's another function obj, but sometimes it's broken. I don't know why though. I'm getting really good results with STL, so you can just bring them into Rhino or Maya or like some other softwares. And I would recommend also to weld the vertices, because sometimes these vertices are needs to be welded. They're kind of open, but it still works really well. So let's try, and let's see where it's, if it's saving the mesh and where it's saving it, right? So I'm going to press E, and you can see that there's some message here. It says it's saved as STL, and if we go into our folder where I have the project here, TOXIMESH bin, and you can see that this is the path of the project that I created, and I see that it's an STL file. You can get the info of that file, and you see that it has 300 kilobytes, and it should be a model created through processing. So this is the tutorial of TOXIMESH. In the next tutorial, we're going to continue working on this script, and we're going to touch on additive waves, just to add some more interesting functionality and some of the sliders that could control the script. So yeah, that's it.